Learning objectives, multiplying matrices, and learn about properties of matrix multiplication. Before we look at matrix multiplication, first we have to look at on when we can multiply two matrices. Matrices A and B can only be multiplied as AB if the number of columns of the first matrix A is identical to the number of rows of the second matrix B. That means that if we have matrices like this, A times B equals AB, and we have their dimensions, so for example, 2 times 3 and 3 times 2, that means the first number 2 in a matrix A is the number of rows, and the second number 3 is the number of columns. We need the number of columns of the first matrix, 3, to be identical or the same to the number of rows of the second matrix, B. Here we have 3 and 3, which tells us that we can multiply these matrices. Here we have an example how these matrices could look like. So here we have 2 by 3 matrix and 3 by 2 matrix. And yes, we can multiply these matrices because the number of rows of the first one, number of columns of the first one equals the number of rows of the second one. Let's look at another example. Here we have 2 by 4 matrix and 2 by 2 matrix. And you can see that here's 4 columns, but here's only 2 rows. So these two matrices cannot be multiplied together. One more extra point here. Look at the two numbers we have over here. 2, which is the number of rows of the first one, and 2, the number of columns of the second one. That's actually going to be the dimensions of the final matrix A times B. So that's good to remember that the second number and the first number of the first matrix must be the same, so you can actually do the multiplication, and the two numbers remaining will give you the dimensions of the final matrix. Here are some practice exercises where you can try to answer if yes, these matrices can be multiplied, or no, these matrices can be multiplied. You can pause the video, answer, and then you can see the solutions at the end of the video. Let's look at the first practice example of multiplication of matrices. So we have two matrices here. Both of them are of dimensions 2 by 2, so 2 rows, 2 columns. And as we said before, to be able to multiply these matrices, these two numbers must be the same. Yes, that works. And we also know that these other two numbers, this one and this one, will give us the size of the solution. So the solution needs to be 2 by 2 matrix. Now, let's start with multiplying. So what we actually have to do is that we take the first row of the first matrix and multiply the second row, the first column of the second matrix. So what we are actually doing, we are doing 2 times minus 6 plus 1 times minus 2. Yeah, so exactly as on the right side, that's how you get the first number. And notice that using the first row and the first column in the second matrix will give us the position 1, 1 in the final matrix. Now, when you multiply these, you get minus 14. And now let's move to another point. So how do we do another point? Let's again take the first row. Now we want to multiply with the second column. So we are getting 2 times 3 plus 1 minus 4. Which when you do the math, you will get 2 times 3, 6, plus minus 4 will give you 2. Again, next number, now we use the first row to multiply both the columns of the second matrix, so now we just move to the second row. And we take 7 and minus 5, and we go again from first column and second column. So we start with the first column, and we have 7 times minus 6 plus minus 5. Times minus 2, which gives us minus 32. Next, we do the last spot, right? The last spot, which is the 2, 2, 2 spot, which is over here. The spot 2, 2, which is also can tell us, well, we are doing the spot 2, 2, so we need to use the second row and a second column. So we are getting 7 times 3 plus minus 5 times minus 4. Which gives us 41. And now let's just put all the numbers together right here. We did it separately for each number, but That's each position in the final matrix. So now when we put it together, our final solution is minus 14 to minus 32, 41. Let's practice together on one more example. So here we have two matrices of size 2 by 3 and 3 by 2. Again, first number is number of rows, second number of column. So again, let's check 3 and 3. So these numbers match. So yes, we can multiply them. And just this is good for like a check of your solution. Like your final matrix needs to be size of 2 by 2. If it's not size 2 by 2, then you have a mistake somewhere. So let's continue with the multiplication. So how to multiply here? We will do it a little bit faster. So we are not going to do it step by step like before in four different steps, but let's do it all in one. So what we have to do first, we take the first row, so 2, 5, 3, and multiply with 6 minus 7 and 2, right? So exactly like this. Now for the second position, or the position over here, position 1, 2, we take the first row and the second column. So 2 times minus 3, 5 times 1, and 3 times 0, and add them all together. Yeah, so always when you're multiplying, just take all the numbers in a column and all in a row and in a column, multiply the respective numbers and add them all together. So now for the position here, 2 and 1, we have to take the second row, minus 3, 1, 8, and multiply with the first column, 6 minus 7 and 2. So we have minus 3 times 6, 1 times minus 7, and 8 times 2, and we have to add them all together. And for last one, minus 3, 1, 8, minus 3, 1, 0. So we have minus 3 times minus 3, plus 1 times 1, plus 8 times 0. And now let's just do the addition and multiplication here everywhere. So for example, if we just look at the first one, we have 2 times 6 is 12, plus 5 times minus 7, that's 30, minus 35. So we have minus 23 plus 6, that should give us minus 17. Yeah, in the second one, again, if we do all the addition, we'll get minus 1, minus 9, and 10. And that's all for matrix multiplication. So always just be sure that the matrices have the right dimension, so you can actually multiply them together, and then you just multiplying the respective parts of each of the matrices. Just remember, you are multiplying row by a column. Here are just 3 practice exercises for matrix multiplication. So be sure that you can multiply them, that they have the right dimensions, and feel free to pause the video now, and then you can find the solutions at the end.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below, and send us a message now. Okay, with that said, let's get back to our lesson.
In the second part of our video, we'll look at properties of matrix multiplication. What do we mean is, let's look at a normal multiplication, just a number multiplication. If we take 2 times 3, that's equal 6. Let's switch it around and take 3 times 2. Well, that's also equal 6. So we can say that 2 times 3 equals 3 times 2, both equal 6. In mathematics, this is called commutative property. And what we want to look at is, if we have two matrices A and B, is the product AB the same as BA? Or another way, is AB equal BA? Or in also other way, is the commutative property does it also work for matrix multiplication? So let's start by getting two matrices. So let's take these two random matrices A and B, and let's first multiply them A times B, and then B times A, and see if we get the same solution. So we take A times B, we do exactly the same as we did before. So we are taking the first row, for example, times the second column, the first column in the second matrix, and that will give us the first number here. I'll just highlight for the first number, and we add them together. Yeah, and if you now do it for all the rows and columns, you get a matrix like this. And if you do the addition, you'll get that the solution of A times B is -9, 8, 18, and -38. Let's look at B times A now. B times A, you just switch the matrices, and we want to now see if the commutative property works as well, because we want to see if the same holds for matrices. So let's now multiply everything again the same way. Start with first row times first column, and when you look at the first column here, the first number here, right away you have 1 times 1, 1 times 1 plus 1 times -7. Well, that's -6, right? Well, the first number doesn't work already. Yeah, we can look at the second number, -2 plus 20, that's -18. Well, sorry, 18. That doesn't work either. So you can see that the solutions are absolutely different, and we can say that A and B doesn't equal B and A, yeah, which can tell us that the commutative property of multiplication does not hold for matrix multiplication. Therefore, and this is very important, the order in which you multiply matrices is very important. Like you have to be sure that you always do it the right way, even if you, for example, want to just put it in your calculator or use some software to multiply matrices. You always have to put them in the right order. We just saw that the commutative property doesn't hold for matrix multiplication, but let's look at some other properties. So for example, if we take numbers 2 times in parentheses 3 plus 4, we can multiply this. We can first add the numbers in parentheses, get 7, and 2 times 7 equals 14. We can also distribute, right? We can also first distribute each number in these parentheses and do something like this. Get 2 times 3 plus 4 equals 6, like 2 times 3 equals 6, and 2 times 4 equals 8, and we get the same answer, 14. This is called the distributive property. Now we want to see if the distributive property works also for matrices. So if we have 3 matrices, A, B, and C, we want to see if this is true, if this works. If A times B plus C in parentheses is equal to the same as AB plus AC. So let's get 3 matrices, A, B, C, and let's start with the first one, A times B plus C. So what are we going to do here? We'll first add these 2 matrices. This is what we are going to do first. We will first add them, and then we will multiply them. So when you add the matrices, that's from the previous lessons, previous videos, you will get 3 minus 2, 3 and 9. And now we do the multiplication. Now we are not going to do it, we will look at the solution, but again, you take the first row times the first column, so that will be 3 times 3 is 6, and plus minus 1 times 3 is minus 3, so the answer for the first number is 3, and the same process for the other numbers, and you get 3 minus 13, 12, and 3. Let's now look at the other option. So let's now distribute. So take A times B plus A times C and see if it's the same, if we get the same solution. So now we first will multiply these matrices and then add them. Again, same process. So 2 times, so for the first one, for example here, 2 times 3 will be 6, and minus 1 times 1 is minus 1. Add them together. The answer for the first number here is 5. Same process then for the to get the other numbers. Plus same for the other 2 matrices, A times C, and we'll get 5 minus 6 times 6, and in the other the product of AC is minus 2, minus 7, 2 and 3. Now just quick addition, and we get 3 minus 13, 12 and 3, and you can see they are equal. Therefore, this is not really a proof, because proof needs to work. This is just a random example, but we can assume, and yeah, I'm telling you that this property holds for matrix multiplication. So you can use this property when you are, for example, solving equation that's involving matrices. Here we have just few more properties that hold for matrices. They are really similar to what we just did. So if you multiply, for example, A times B first and then times C, it's the same as multiplying first BC and then with 8. But careful, the order must be the same. If you change the order of the matrices, then it's like in the first example we were looking, then it wouldn't hold. The commutative property doesn't hold. Yes, similar here when you're multiplying with a scalar k. The k is just a number, as we did in previous videos. And then here you have the distributive property. We showed the left distributive property, and it also holds for the right distributive property. It's the same process. And if you want, you can use the 3 matrices in a previous example and try that the right distributive property works as well. If you haven't finished the practice examples, you can pause now, don't continue, because now you will see the solutions. You can pause, try, and then come back here and try and see the solutions. So for the first 2 exercises, we were asking if it's possible or not possible to multiply the matrices, and it was that the first one, yes, we could multiply the matrices. The number of columns of the first one, number of rows of the second one were the same, but not in example number 2. And then for the multiplication, we have these 3 solutions. Yeah, interesting solution in number 5. You could see that both of the matrices, we had matrix of dimensions 2 by 1 and 1 by 2, so they were smaller than the actual solution. They had smaller dimension than the actual solution.